Hello, in this video I'm going to be showing you how to build this, a 3.5-inch FPV drone for under $200. I'm going to show you exactly which parts to buy, how to assemble it, how to set up the drone, and then the flight footage. But first, some background about this class of drone. This is a 3.5-inch drone, which means it spins props that are 3.5 inches in diameter. But the most important thing about this drone is its weight. The drone, with its battery, I'm using a 4S 650 pack, weigh under 250 grams. This is really important in the United States because any drone over 250 grams has to be registered with the FAA. However, if your drone, including the battery, as it would fly in the air, weighs under 250 grams, you don't have to register it. To end up with this setup of drones, FPV pilots took the long-time favorite 5-inch freestyle FPV drone and they shrunk it down just enough to get everything to weigh under 250 grams, and that's how the 3.5-inch freestyle FPV drone class was born. This class of drone flies really similarly to a 5-inch freestyle FPV drone. It's just a little bit smaller and lighter. And so due to the 250 gram rule, I do think the 3.5-inch FPV drone class is going to get bigger and bigger every year. And so let me show you how to build it, starting with the parts. All the links to the parts I'm going to be using will be in the description below. For the frame, we're going for the Flyfish RC Volodor VX 3.5. This frame costs just around $30 and it comes with a lot of premium features, especially when it comes to the camera mounting. It comes with aluminum side plates to help protect the camera and the front end in case of a crash, and it comes with 4 different soft mount silicone gel inserts for a variety of different cameras. We're building this setup with an analog video system, but later on, if you want to upgrade to the DJI O3 Air unit, well, this frame comes with everything you need to install the O3 Air unit. It's just a direct drop-in fit, so this makes for a really good upgrade path if you want to upgrade your drone later on. Also, when you're buying this frame, make sure you get the 3.5-inch version of the frame, since they also sell this in just a 3-inch version, and that's going to be too small. So make sure you select the VX 3.5 and not just the VX3. For the motors, we're going for Yasuda 1505 motors. These cost just $30 for a full set of 4 motors. That's a really good deal. They come in 2 different kV values, 2650 kV as well as 3750 kV. I'm choosing to use the 2650 kV motors. They're going to produce a little bit less top end thrust, but they're going to be slightly more efficient, and that's fine with me because I'm not going to be doing any kind of crazy freestyle moves. But either one will do just fine. If you do have a little bit more wiggle room in your budget, for just $10 more, so $40 for a full set of 4, you can get some really nice T-Motor 1604 motors. These are very high quality motors that spin very freely, and so it can be worth the upgrade. For the flight controller stack, we're going for the SpeedyBee F405 Mini. It costs just $55, and it comes with the usual SpeedyBee goodies like Bluetooth configuration, which means you can set up this drone completely from your phone. Overall, it's just a really good value like SpeedyBee stacks usually are. For camera, I'm going to specifically recommend the Caddx Ratel 2 camera. I normally recommend either the Ratel 2 or the Runcam Phoenix 2 cameras since they're both very good high quality cameras. But in this case, the Phoenix 2 cameras have wires coming out the very center top of the camera, and that's actually going to interfere with our stack. Because our 3.5-inch frame is so small and compact, the layout of the wires is going to matter a lot. So if we go for the Ratel 2 camera, the wires are going to come out the side of the camera, and that's going to be a lot of help in our build. For the video transmitter, we're going for this Solo Good or Cyclone 1-watt VTX. It costs just $20, it comes with the antenna, and it's really flexible with its mounting options. You can either mount it to a 30x30 slot or a 20x20 slot, which is what we're going to be using. If this video transmitter isn't available by the time you're watching this video, I would also highly recommend the SpeedyBee TX800 video transmitter. Out of all the parts in this build, this video transmitter is the most likely to be out of stock because these small video transmitters aren't used in the big conflict that's going on overseas. Usually a lot of the parts are going into the huge 2 or 3 watt VTXs, so it's possible this is going to sell out and not be restocked. Before making this video on this 3.5-inch drone, I actually built and filmed an entirely different 3.5-inch freestyle FPV drone video, but by the time I got around to start editing it, the frame and the video transmitter I was using was out of stock, so I had to start from scratch. And so this is what you're watching now. For RC radio system, we're going for Express LRS, so I'm using the JHEMCU Express LRS receiver. This receiver is just barely small enough to fit into the receiver bay on the Volador frame. If you do want to have a slightly easier time fitting the receiver in, I would also recommend the Happy Model EP1 receiver, which is really, really small. If you don't already have a radio, I really recommend the Radio Master Pocket Express LRS version. It usually costs around $60 and it's built like a tank. For the battery, we're going for the Genzace Tattoo R-Line 650 mAh 4S pack 95C rating. You don't have to specifically get this battery, you should just get any 4S LiPo around this weight class. If you don't already have a set of analog goggles, I'd highly recommend a pair of genuine Eachine EV800D goggles. They cost around $100 and they're not the cheapest set of goggles, but they do work really well. They have a nice set of diversity receivers built into them, which means it uses the signal from both antennas at the same time in order to give you the best image quality possible in the monitor. They aren't very comfortable, so most of the time I don't actually wear them strapped to my head, but I have them mounted on a tripod. But overall, I think they're definitely worth the money. Plus, analog goggles are universal, so once you have one set of decent analog goggles, you can use them in the future with any future analog drone you get. One thing to look out for is that these are so popular that people have cloned and copied them, so you don't want to get a knockoff. Don't get the ones that have a little yellow stripe around the antenna. Don't get the ones that aren't branded Eachine. You want the genuine Eachine goggle. As far as tools go, one of the most important tools to have is a computerized soldering iron. I recommend the Pine-Sol, which I have here, or also the TS100. These irons have temperature sensors that are built into the end of every single soldering tip, which makes them react really fast to changes in temperature, which makes the soldering process a whole lot easier. Don't skimp out on the soldering iron. Compared to any cheap $10 pencil soldering iron, these computerized irons for just $30 or $40 are going to make a world of difference. This small build is going to almost exclusively use screws with a 1.5mm hex head, so you don't want to be stuck there spinning a tiny little Allen L wrench. If you don't already have one, pick up a decent 1.5mm hex driver. And finally, some blue thread locker, a set of tweezers, and soldering flux is also really good to have. But anyways, let's get on to the build. Let's get this all out onto a tray. Nice, okay. Let's start the day off right by doing a dry fit of the components first. We're going to screw on as many components as we can onto the frame first to figure out where all the wires and stuff are going to go. Let's start off by mounting the SpeedyB stack by using the longest M2 screws that are included with the stack. For the video transmitter, use pliers to bend off the extra larger 30x30mm mounting tabs. We won't need those. And then use tweezers to mount the gummies into the 20x20 mounting holes. When it came to mounting the motors, I encountered a little quality control issue. The motor mounting holes were actually splayed out a little and not parallel. So to fix this, I screwed in some long M2 screws into the motor mount holes and used those screws as leverage to bend the motor mount holes straight and parallel again. This is also why I recommend spending a little bit of extra money and getting the T-Motor 1604 motors rather than these Yasuda motors. Alright, the dry fit is complete. Here's most of the components all just screwed onto the frame. For most of the parts, the included screws that the parts come with are going to be just fine. So the motors came with little M2 screws, so those will work just fine there. The SpeedyB stack came with 2 different lengths of stack screw sizes, and I'm using the longest ones, and looks like it's just going to be barely long enough to work. The video transmitter doesn't come with any screws, so I had to supply my own M2 by 10mm screws and nuts for that. And so that's the only place where I needed to supply my own M2 screws. If you don't already have something like an M2 screw assortment kit, I recommend you pick up one of those as well as an M3 screw assortment kit. It's always just handy to have a lot of different sizes of screws laying around just for cases like these where you just need to have some screws. Now, one of the main reasons why we're doing this dry fit is also to figure out where wires and stuff are going to go before we solder them. And so the capacitor is a really crucial part for the speed controller to help soften the voltage spikes from the battery. And we need to find a good place for the capacitor to go. Now, if you look at the SpeedyB stack, I actually have it mounted backwards. So the arrow is actually pointing this way towards the back of the quad, and the battery pads are at the front. So basically I flipped the standard orientation around. That's because I think it's going to look like it's a lot easier to fit the capacitor at the front of the quad right behind the camera because there's nothing going on in between here versus at the normal place. So let me actually flip it around to what's the traditional mounting orientation. So normally the stack is sort of intended to be mounted like this. So the battery leads are coming out here, and then you also have the capacitor here, but there isn't really a lot of space to put the capacitor. I guess I could mount the capacitor over here in the back above the VTX, but in the future, if I want to switch to the O3 air unit, which I actually have right here. So this is a nice frame because if you later on want to upgrade to the O3 air unit, this is a direct drop-in fit, so we can grab an O3 air unit and this will just fit in right there. But you notice that the O3 air unit basically takes up this entire back half of the quad, and so that means in the future, if I do want to upgrade to it, I can't have the capacitor hanging out in the back here. There just isn't enough space. Also, you do want to take into account the battery lead. So here's the battery lead that the SpeedyBee stack comes with, and it's actually kind of short. If you notice, if I would solder it in the normal way, it'll land right about there. And then you put the top plate on. There's barely any wire sticking out there. That's not a lot of room there to work with. And so I think for this build, if we just flip the stack 180 degrees, we can compensate for this in the Betaflight software. We should be able to mount the capacitor in over in the front. We can have the battery leads coming out the front, and we can wire them actually through this hole here in the front. So it'll look kind of like that. And I think this is going to be the way to go. I'd say the only one downside to this method is that the XT30 plug doesn't actually fit through this little hole in the frame. So I'm going to have to solder it like this, like after feeding it through. The top plate and the stack are going to be permanently connected like this. Overall, not too much of a big deal. I think in the long run, this is going to be the cleanest way to go forward, and it'll allow me a really easy upgrade path to swap in the O3 air unit if I wanted to. So we have a solid plan set. Now it's time to solder in the capacitor and the battery lead. For the capacitor, I bent the leads up in a U shape and I fed that through the bottom of the ESC. After doing a dry fit of the ESC and the capacitor in the frame, I found that this was the best position in order to get the capacitor to fit nicely in the little hole in the front of the frame. Next, it's time to solder the battery leads to the ESC, and don't forget to follow the plan like I did, and remember to route the wires through the top plate first before you start soldering. I forgot to do this at first, so later I had to undo my soldering job and then put the top plate through and then redo the soldering job again. Now that we have the battery lead soldered on, it's time to plug in our ESC and flight controller together using the included cable, and then try plugging it in through our smoke stopper in order to check for shorts. It looks like we're good to go here, so now it's time to upgrade the firmware. Alright, the flight controller and ESC is all hooked up. Now it's time to update the firmware on the flight controller. All I'm going to do is plug it in to Betaflight. We don't need the battery plugged in at the moment, we just need the USB connection. So let's plug it in, and let's hope Betaflight recognizes it. Okay, we have the flight controller plugged in, we can move it around, we can see the gyro is working, that's all fine and good there. Let's look over to the top left and we see we are on firmware 4.4.2, which is a little bit old, about a year old, so let's go ahead and do a firmware update. So the first thing I'm going to do is go and hit update firmware. We're in the firmware updater screen, and we're going to use auto detect to figure out which board this is. It also says up at the top left sometimes, but we hit auto detect, and this is the SpeedyBee F405 Mini. And now the firmware, the latest firmware is 4.5.1. Now we can't update the firmware from here because our flight controller isn't in firmware upgrade mode. So what I'm going to do is I'm actually going to go back to the welcome screen and hit connect. And then we're going to go into the bootloader DFU mode via this button right here. You also can use the physical button on the SpeedyBee to put it into this mode, but I think this method is a little bit more reliable. And at the top right, you can see it switched to DFU bootloader mode, so that's correct. Instead, if you get a driver error, you have to go and download Impulse RC Driver Fixer, which will download the proper DFU driver. But I've already done that on my computer. So now we can go back to the firmware update screen. The auto detect won't work because we're not in the normal mode, but we can remember what the board was. It's SpeedyBee F405, SpeedyBee F405 Mini, and we already have the latest firmware version selected. Great. So we're going to load the firmware online, and then we're going to flash the firmware. All right, programming successful. That's good. Let's double check. Let's connect back to Betaflight, and now at the top left we see we're on the latest firmware 4.5.1. Cool. And now we can move the flight controller again, and we can see it's moving properly. That's great. And one other thing, let's calibrate the accelerometer while we're here. So I'm going to hold the flight controller level on my table as best to level as I can get it, which is about there. I'm gonna hit calibrate. The flight controller is now all set up and ready to go, but now I'm gonna take the extra step and upgrade the ESC to BlueJ firmware. So to do this, first I'm gonna disconnect from Betaflight, and then I'm gonna unplug the flight controller. Next, I'm gonna plug in power to our system, and then I'm gonna remember to close Betaflight. Then I'm gonna plug in the flight controller, and now we're gonna go to escconfigurator.com. So this is a website where we can actually update the firmware of our ESCs. We're gonna hit connect. So now we're connected to our ESC via our flight controller. Now, if you had Betaflight open before this, Betaflight might take hostage of the port, and so you can't connect. So it's always important to remember to close Betaflight. First thing we're going to do is we're going to read the settings. So we're going to read the stock ESCs, and this will take a minute or so. Okay, and it's read the ESCs, and you could see on this list ESC 1, 2, 3, 4. So it's properly read all the ESCs. That's great. And currently they're running BL Heli S. We want to upgrade all of these to BlueJ. So I'm going to hit flash all ESCs. And now under firmware, instead of BL Heli S, I'm going to select BlueJ. So this will allow us to do some more advanced tuning options like bi-directional communication. Select a version, we're going to choose the latest version. For PWM frequency, let's just go for the middle one at 48 kilohertz. And now we can flash. This will take another minute to flash all the ESCs, and you can watch the little progress bar as it flashes each ESC. By upgrading to BlueJ, this will allow us to enable bidirectional D-shot motor protocol, which means the ESC will talk to the flight controller and the flight controller will talk to the ESC. It'll be able to respond faster and control the motors better with this bidirectional communication. So there we go. And now that it's done, you can see all 4 ESCs, BlueJ, 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 BlueJ. That's great. Before we disconnect, we're going to want to change our minimum startup power from 1010 to 1030 and our maximum startup power all the way up to 1040. Our motors are going to need a little bit of startup boost. And then remember to write the settings. So now we can hit disconnect. And just like that, our stack is fully updated, so let's get it back into the frame. This is a really tight frame to work with, so I'm really pleased we could fit the capacitor right there. You don't want the capacitor leads to be touching the carbon fiber because carbon fiber is conductive. I think I have a good solid 3 or 4 millimeters of clearance all around there, so I should be good there. The next stage of the build is to solder the motor wires to the ESC. To do this, first trim down the motor wires to the right lengths. These motor wires needed just a couple millimeters shaved off the ends of them. Next, tin the pads on the ESC, which means just applying a little bit of solder to them and making sure it flows evenly. And then tin the motor wires, which is the same thing, you're just applying solder just to the motor wires to make sure the wire is completely covered in solder. Once both the pads and the wires are tinned, then you can bring them together and solder them together. For this tiny build, it really helps to have tweezers to help hold the wires. Repeat this for all 4 motors, and then you're all set. Next, it's time to wire up the video transmitter. The wiring harness has 2 extra wires, 5 volt and ground, in case you're using this in something like an airplane where you don't have a flight controller. But in our case, we do have a flight controller, so we don't need those connections, and I'm using a little knife to pry out the prongs and removing the 5 volt and ground lines in order to make the wiring just a little bit neater. We're left with 4 wires that we have to hook up: our video signal, our data line, 9 volts, and then ground. I'm going to be posting the full wiring diagram for this exact build in the video description below, so if you want to follow along, you can reference the wiring diagram to solder it exactly as I did. Next up, we have to wire up the Express LRS receiver, so solder the 4 wires to the receiver first, attach the antenna, and then shrink the included clear heat shrink over it to protect it from shorts. The frame comes with a 3D printed receiver holder that is just barely big enough for a receiver. After stuffing the receiver into the holder, screw it on to the bottom of the frame. Next, route the wires through the bottom of the frame and start soldering them to the flight controller. There are 4 wires, 5 volts, ground, and then the 2 UART wires. When soldering the UART wires, remember that they're always crossed, so RX goes to TX and TX goes to RX. Finally, it's time to wire up the camera, which only has 3 connections: 5 volts, ground, and video signal. I'm choosing to leave these wires long in case I want to reuse these parts in a different build. If you want to tidy up the wiring a bit, you can cut them down shorter. That takes care of all the wiring, so it's time to put the drone back together again. First, remember to attach the VTX antenna into the VTX, since we will be powering up the VTX in the next step. Then you can finish mounting any components you haven't mounted yet and screw on the top plate. The final stage of our build is to set up the drone in Betaflight Configurator. The thing is, this process takes a really long time and it's kind of boring, so I'm going to save this for the very end of the video for those of you who have the drone in front of you and want to follow along. In the meantime, let's pretend you finished the setup and let's get ready for our first flight. The props we're using for this build are HQ Prop T3.5 props. Let's use M2 screws to screw them onto the drone, making sure we have them in the right orientation. And just like that, the build is complete. It's a nice day out at the pond, so it's time to take the 3.5-inch quad out for a test flight. The footage you're seeing is the DVR recorded footage from my goggles. In the future, I really do want to show you some HD quality footage from onboard the drone, so I'm on the lookout for a good, small, high quality digital camera. I'm kind of leaning towards the Insta360 Go, but if any of you have any suggestions, please let me know in the comments. Still, for analog video, I do think the footage does look pretty good, and I think it's thanks in part mostly due to the Cadex Ratel 2 camera. It's just a really good camera, and that's why I always recommend springing for that or the Phoenix 2 in my builds. You can get really cheap cameras for $10, but the quality is so much worse than just spending the extra $10, $20 total to get the Ratel 2 or Phoenix 2, because you can get really, really nice footage like this. Anyways, my first impressions from flying this is that I can see why this is the preferred setup for FPV freestyle under 250 grams, because this thing flies exactly like a 5-inch freestyle drone. I don't think I could tell in the air, if I didn't know it already, that this was a 3.5-inch. I would think that this is a 5-inch. This thing is just so fast and nimble, it's really, really fun to fly. Now, I am not the best freestyle pilot, so for these flights, I'm not going to do any crazy like Matty flips or anything. Mostly, I'm just going to fly really fast and just do some dives or so. But while I'm doing it, I am having a lot of fun. And if you take a look at the throttle valleys and the amp draw, I'm not really holding back on it, and it still is really efficient. So my amp draw is really low and my current used is low. So even though I am ripping around, I am still going to get 5 minutes of flight time, which is really awesome. As far as noise level goes, the sound coming from the quad is significantly quieter than from the equivalent 5-inch quad. Most of the people around me couldn't even tell I was flying a quad, because once you're 100 feet away, it's pretty much silent. I think this is mostly just due to how lightweight this is, so the props don't have to spin very fast, and so they don't end up creating a lot of noise. If you do throttle up above 60 or 65% throttle, the sound does increase and it becomes more noticeable, but even so, it's still a lot quieter than the 5-inch, which will make this huge echoing kind of swarm of bees shriek if you go that high. And so this is a really great way to rip around in a small park or something without drawing too much attention to yourself. I can see why this 3.5-inch freestyle class is becoming so popular nowadays. It flies so similarly to a 5-inch, it's just as much fun, but it's just so much quieter, so much less noticeable, and you don't have to register it with the FAA, so it's just pretty much a win on all fronts. I think the only downside for a small drone like this is that it would be more affected by wind. The day I was flying, it was gusting up to around 10 miles per hour, so it wasn't a completely calm day, and I didn't really notice the wind at all too much. So unless you regularly fly in an area with big 20, 30 mile per hour wind gusts, I don't think you're going to notice too much of a difference. The only change I'd make to this build at this point is to change out the VTX antenna. So the stock antenna is a standard dipole antenna, and I think that's kind of hurting the signal quality. I'm normally used to having very, very little signal disruptions, but occasionally during the flight, you might have noticed in the video, I'm getting more than the usual amount of static. And so I think switching to a proper RHCP antenna instead of a linear antenna is going to help in the signal quality a lot. So if I do find one that fits nicely into the frame without requiring any special kind of 3D print or anything, I'll also post a link to that in the description below. Anyways, I'm really pleased with how this drone turned out. It's my favorite drone to fly right now because it's so stealthy and yet it's so fun to fly. If you don't already have a 3.5-inch drone in your hangar, I think you should really consider building one. It's a lot of fun. Anyways, thanks for watching. If you aren't already subscribed, I'd really, really appreciate it if you could subscribe to my YouTube channel. That's it for this video. If you want to stick around for the full beta flight setup, then that's coming up next. See ya. Alright, it's time for the beta flight setup for the 3.5-inch drone. First, let's get the receiver bound. Since we have the receiver on the 4v5 pad, all we have to do is power up just the flight controller, no battery required. And now our Express LRS receiver here at the bottom is powered up, and I'm going to wait 1 minute for it to go into binding mode. That means the red light is going to start flashing rapidly after 1 minute. Okay, it's been 1 minute. The red light is flashing rapidly, which means it's in Wi-Fi mode. I'm going to go over to my list of Wi-Fi connections, and I'm going to connect to the Express LRS network using the password Express LRS. Okay, I'm connected to the receiver now, so I'm going to go to the web address 10.0.0.1, which is the web address for the Express LRS receiver. So here we are directly connected to the receiver via Wi-Fi. And here I'm going to enter in the binding phrase. I'm using the binding phrase pineapple. For your binding phrase, you should use your own unique word. So it's pineapple, and everything else should be fine. So I'm going to hit save. Next, I'm going to power cycle the quad, and hopefully my radio is going to connect to the receiver now that I've entered in the binding phrase. So since the receiver has the binding phrase pineapple, my radio already has the binding phrase pineapple in it. They should automatically connect the next time I power it up. There we go. I get some bars on my Radio Master Pocket. Let's go over here in Betaflight now to the receiver tab. And now let's hopefully see that it's recognized. So I'm going to jiggle the sticks. And great, it's all working perfectly. So our receiver is connected and Betaflight is recognizing it. Now we have to set our arm and mode switches. So we always want the arming switch to be on aux 1, and I'm using this top right switch on my Radio Master Pocket. So you can see that aux 1 is going up to 2000 for armed. And then I use a rocker switch on my Radio Master Pocket to set up my angle mode. So you can see aux 2 can go up to 2000 for angle mode. And 1000 for acro mode. So keeping that in mind, I'm going to go down to the modes tab and I'm going to set that up. So first I'm going to make sure there's no already existing modes, because sometimes by default some modes can be enabled. Good, nothing is enabled. So we're all starting fresh. I'm going to add range to arm. We always want arm to be on aux 1, and we want that to be the upper half of the range. And then we want angle mode on aux 2, and we also want that on the upper half of the range. I'm going to hit save. And now if we hit the arm switch, you can see that it's armed. If we hit the angle mode switch over here that I'm using, we can see it goes into angle mode. Cool. So that is all the receiver and mode settings that we have to do in Betaflight. Next up, we have to set up the video transmitter, the camera, and the on-screen display. So what I'm going to do is I'm going to unplug the USB cable. The drone is completely unpowered.
Telemetry lost.
Next, we're going to prepare the battery, make sure the battery is charged. And I'm going to prepare a cooling fan. The VTX is going to get hot while we configure it, especially because the quad isn't going to be flying. The VTX is designed to be constantly cooled while in flight, and so it's not designed to be powered on and sitting up on the bench for a long period of time. So to simulate it flying, I'm just going to take a little USB computer fan, and I'm going to point this at the quad towards the VTX so that it can remain cool. To help me set up the analog OSD on the drone, I have a tiny little 3-inch portable wireless monitor. So this is basically going to act as my analog goggle. It's just a lot more convenient to look at this little screen instead of having to grab my goggles and look through the goggles itself. I'm going to power that on. Next, I'm going to power on the drone with the battery, making sure that my USB cable isn't plugged in yet, because the order of operations does matter. We're also going to make sure that the props are off, because we will be configuring the motors as well. So now that the drone is powered on, we're safe to plug in the USB cable. All right, so now it's time to configure the VTX. So I'm going to go over to the ports tab. We've soldered our VTX's data port to UART1. And so we want to go over to UART1 and select the VTX as the peripheral. And our video transmitter uses the smart audio protocol. So I'm going to do VTX TBS smart audio. I'm going to hit save and reboot. Okay, next I'm going to go down here to the video transmitter tab, and hopefully it should be recognized. And yep, you can see at the right it says device ready equals true, and the VTX type is smart audio 2.1. So that means our flight controller is receiving good data from our VTX. However, right now we don't have a VTX table set up, so we can't set any of these band, channel, or powers because Betaflight doesn't know what to tell the VTX. It doesn't actually know the specific details of what the VTX can do. So we're going to download the VTX table from the manufacturer's website. For this VTX we're using, it's called VTX1000.json. So I'm going to hit load from file. I've already downloaded it. And over here it says VTX1000milliwatt.json. That's the file we want. So I'm just going to hit load, and there we go. It has populated our VTX table, and we have our power values over here. I'm going to set my default values of band, channel, and power. I personally fly on band A, channel 6. We're going to go with 25 milliwatts so that our VTX doesn't overheat. So we're going to do 25 milliwatts. and then we're going to hit save. And I'm going to remember to change that later before I actually go fly, because we don't want to fly on 25 milliwatts. This is just for configuring it on the bench. I'm going to hit save. And right away you can see that the image has popped up on the monitor, because we set, I've already set this monitor to band A channel 6, and now that we just set the drone to it, we can see the image in the little monitor here. That's great. So our VTX is configured properly, it's receiving data. Now I want to configure the on-screen display. So I'm going to go over to the OSD tab. I'm going to set up my OSD. I'm going to scroll down over here, and by default it's on HD for some reason for digital systems, but we want to do analog, so I'm going to set it to, so let's try hitting PAL. Okay, and now we're going to start populating the elements. I really like the artificial horizon, so I'm going to start with that, and then we're going to start with the battery average cell voltage, because that's the most crucial piece of information. And now we can see that it's all a jumbled mess up here, so I'm going to take a minute to reorganize this. This is usually the main reason why I stick the Betaflight setup to the end of the video, because this is kind of boring and tedious to try and get all this stuff aligned properly. So hopefully I can do this relatively quickly though. Now you're going to notice that on the OSD nothing appears. That's because usually you need to do a full power reset in order to get the VTX and the OSD chip to work properly. So we're going to try that. So I hit save here, we don't see it. What I'm going to do is I'm going to hit disconnect from Betaflight. I'm going to disconnect the USB cable. I'm going to disconnect the power. I'm going to wait a second.
Telemetry lost.
I'm going to plug the power back in. And there we get the OSD. So it turns out this camera needs to be in PAL mode for it to work. So that's just another quick little tip. Usually NTSC works, but I guess for this one it's PAL. Let's actually go to the configuration page and update the craft name, because sometimes I get confused when I record. I forget which drone I'm flying, so I'm going to do 3.5 inch as the craft name. I'm going to do save and reboot. And let's get the craft name up on the OSD. What else do we want to get up here? We want the battery current draw. We want the milliamp hours drawn. Those are usually the things on the OSD. You can of course customize this to whatever you want, what data you want on your OSD. 3.5 inch over there. I want throttle value to be at the top right. Usually the stuff at the top is going to be the less important stuff, because I'm generally not looking at that as often. I want the timers at the bottom. I want flight time right up on top, and then the on time down here. Cool, so that should be my OSD setup. So we're going to hit save on that. Okay, so our receiver was set up, our OSD is set up, our video transmitter is set up. Before I forget, let's go back to the video transmitter tab, and we're going to set the power level properly. So I'm going to do low power disarm equals on, which means while it's disarmed, we're going to stay at 25 milliwatts. But then I'm going to set the actual power value. We probably don't need 1 watt for this little guy, so I'm going to do 400, so hopefully it doesn't overheat. So what this means is once I arm, VTX is going to go up to 400 milliwatts. The moment I disarm, when I'm landing, it's going to go back down to 25 milliwatts. So I'm going to hit save on that. All right, so next, let's go over to the motors tab. So we have to configure the motor order and then the motor direction. So in the motors tab, this may be different from everyone depending on how the motors are wired up and such. So first of all, let's go over to the reorder motors wizard. So the Betaflight needs to know which motor is in which position. If you look at the little screen here, it says 1, 2, 3, 4. So that's the order Betaflight is expecting. So let's just double check to make sure that's correct. This is usually correct by the ESC manufacturers. By now they've gotten it all right, but we always want to double check to make sure. So I'm going to hit reorder motors. I understand that there's no props because the motors are going to start spinning up. And let's start this wizard. So it's pointing this way, so the top left motor is spinning. Now the bottom left motor is spinning. And the top right motor is spinning. And the bottom right motor is spinning. We hit save on that. Cool. Now we're going to go back to the motors tab. Okay, so our motor order is now correct, but now we need to do our motor direction, which way the props are spinning. So you can see here on the Betaflight diagram which way the prop should spin. So they're pointing in and up towards the front, in and up towards the front, in and down towards the bottom, in and down towards the bottom. So I'm going to do the motor direction wizard. I understand the risks. We'll do it individually. So I'm going to hit motor 1, which should now be this one. And this is spinning the correct way. You can see it's spinning that way. That's correct. Number 2, that's correct. Number 3, that's correct. Ooh, we're 3 for 4 right now. Let's see if the last one's going to be correct. It's all correct. That's pretty rare. So the motor direction is actually all completely right from the factory. So that's pretty lucky. So we don't have to do anything. We just hit close on that. What else should we do? Since we upgraded to Blue Jay, we can do bi-directional D-shot. So let's go ahead and enable that. So we're going to hit agree on that. Now let's hit save and reboot. Let's go back to our motor tab just to make sure that's working properly. Yep, we do have bi-directional D-shot enabled. Let's see if the motors will spin with bi-directional D-shot. Yep, it is. So that's great. One super important part that I forgot to do was set the board orientation correctly. Remember, we reversed the direction of our flight controller, so now we have to compensate that in the Betaflight software. So if I tilt the drone forward, it actually tilts backwards because it's backward. So to fix it, we go into configuration and we set the board and sensor alignment. We want our yaw degrees to be 180 because we yawed it 180 degrees. So we'll do that. We'll do save and reboot. And now if I tilt the quad forward, back, left, right, yaw left, yaw right, it's all correct now. So don't forget to do this, very important. So that should be it for the setup. We set up the OSD, we set up the VTX, we set up the motors, we set up the receiver. This thing is ready for a test flight.
Definitely. Yeah.